Heisenberg's uncertainty.
Heisenberg's uncertainty principle. And what we have to do today? What we have to do today, tell me? We have to look at the hydrogen spectrum, right? Absorption spectrum, emission spectrum, correct? So please write spectrum, first of all. What is an spectrum? Before that, let me show you some video. Thank you again, spectrum. Yeah, right. Dispersion of light into series of color bands is called spectrum. There are two types of spectrum, right? There are number one, continuous spectrum. So what is continuous spectrum? When spectrum has no gap in between, when spectrum has no gaps in between, it is called continuous spectrum. Discontinuous spectrum, when spectrum has gaps in between the colors, it is called discontinuous spectrum.
Sir, can you scroll up?
Sure. Done, guys? Yes or no, please?
Yes, sir.
Okay. Now see. For example, the electron was present here, let us say. Okay, and what did we do? We heated the thing, or we gave it electrical energy. So what is going to happen? This electron will absorb energy and it will jump into some higher level. It will jump into some higher level. So it jumped into some higher level. Now there are million, even if we take 1 mole. So 1 mole is equal to 6.022 into 10 to the power 23 atoms. Okay, so if you just take 1 mole of any gas, it will have million of atoms. Now, some of it will be getting excited. Okay, some of it will be getting excited, and then what is going to happen? They will fall back also. So they will get excited and they will fall back again. So this process will continue. Okay, so I'm showing this in one atom only, but please remember that it is going to happen in different atoms. Some atoms are getting excited. Those who are excited, they are getting falling back. Again, those who have fallen back, they are getting excited. Okay, so this thing continues. Now, when you see that when it is going back here, when it is falling back, it has high energy here. It has high energy here, and here it has low. When something goes from high to low, what it will do? It will emit energy. It will emit some energy in the form of light. And this is the light that we are going to get. Okay. Now, when this electron is getting excited, it can get excited into different orbits. Can get excited into different orbits. And when it is falling back, it can also fall back into different orbits. Okay. Now, this green orbit, which is giving some light here, that light will be inherently different from the light given by this green line. Okay, and that is why we get different types of different frequencies, and different frequency means different color of lights when we are doing the diffraction. You got this? Yes or no? Please tell me the 2 points. First of all, what causes the spectrum falling back of electron? Falling back of electrons from higher to lower states, lower energy states. Okay, and that causes what? Now, since these all lines are what getting emitted, we call this emission spectrum. Aisha, Iram, and Fahad, you got this? Yes or no? Please tell me.
Sir, I had a question.
Tell me.
If while falling back, you said that they lose some energy in the form of light. So, sir, if this process is repeating itself, so ultimately the atom won't be stable and would fall apart or something.
If you give enough energy, then the electron will ionize. बस यही कह सकते हैं. Atom will get ionized. अगर ionization energy तक का energy आपने दे दिया, electron चला जाएगा infinity तक. The nucleus will have no influence, and that is why it will not fall back. So atom is getting ionized. That's the only thing that can happen. Right, Fahad?
But sir, won't it be keep changing its energy level? So how is it following the law of conservation of energy?
How it is sorry, what?
Sir, if it keeps changing its energy levels, then how is it following the law?
No. ये ऑटोमेटिकली तो नहीं चेंज हो रहा ना फहद. आप फिर से सोचिए आप क्या बोल रहे हो. ये एनर्जी क्यों बढ़ रही है? Why the energy is increasing of electron? अपने आप बढ़ रही है क्या? Yes, Fahad, tell me. नहीं, हम एनर्जी दे रहे हैं तो बढ़ रही है. एनर्जी इज कंजर्व्ड. Yes or no?
किस फॉर्म में दे रहे हैं एनर्जी?
इलेक्ट्रिकल फॉर्म में दीजिए, आप हीट फॉर्म में दीजिए, दोनों फॉर्म में. अभी तो आपने जो देखा दैट वाज इन इलेक्ट्रिकल फॉर्म. जस्ट नाउ यू सॉ.
ओके.
अब दूसरी बात, जब ये नीचे गिर रहे हैं, है ना, व्हेन दे आर फॉलिंग बैक, तो वो एनर्जी तो रिलीज कर रहे हैं ना, राइट? बिकॉज व्हेन दे आर इन हाई एनर्जी, दे विल हैव हाई एनर्जी. और जब यहाँ पे लो एनर्जी है, तो ये जो डिफरेंस है, यही तो ये एमिट कर दे रहे हैं. सो व्हेन दे आर एमिटिंग एनर्जी, व्हेन दे आर गोइंग फ्रॉम हाई टू लो, सो हियर आल्सो इट इज कंजर्व्ड. राइट फहद? You got disconnected. Aisha and Iram, you got this? Yes or no? Please tell me.
So,
हाँ बताइए.
ये जो जंप कर रहे हैं राइट इलेक्ट्रॉन्स, इस वजह से डिफरेंट कलर्स आ रहा है.
हाँ ये green वाले से different color आएंगे because it is in high energy it will go to low energy and when they are going from high to low they will lose some energy they will emit energy because आपको याद हो तो हमने लिखाया था for in Bohr's model the Bohr model of atom it says that each orbit has its own energy अगर आप वहां से transition कर रहे हैं so it will be associated either with emission or absorption if you are going from high to low there will be emission of energy if you are going from low to high there will be absorption of energy याद आया नहीं याद आया
Yes, sir.
नोट्स याद आया नोट्स में होगा आप लोग पढ़िए रिवाइज किया था नोट्स आपने इरम नोट्स रिवाइज किया था नहीं किया था the electron is present in particular orbit then it can neither radiate nor energy nor absorb energy so the energy in each orbit is fixed next I have written energy of electron changes if it goes from one orbit to another ठीक तो यहाँ पे मैं आपको ये भी एक्सप्लेन किया था when the electron is coming from higher energy to lower energy the energy is the light is emitted and when the electron is going from low to high the energy is absorbed okay so Fahad I missed you in between tell me what you were asking you're saying something
सर नहीं हो गया कुछ नहीं
हो गया क्लियर है
Yes.
okay right here emission spectrum emission spectrum like it is observed it is का मतलब emission spectrum आप लोग लिख लीजिए emission spectrum emission spectrum emission spectrum is observed when the radiation emitted from substance that has absorbed energy is analyzed okay so first we give energy and then the electron falls back and when we see the electron falling back we see an emission spectrum let me know when you're done done okay right next absorption spectrum right here when a continuous electromagnetic wave is allowed to pass through a solution or a gas and then the transmitted light is analyzed we obtain a absorption spectrum Let's write this down. Let me know when you're done. Let me know when you're done.
Done, sir.
Done. Okay. Now let us see what is absorption spectrum. Okay. So in absorption spectrum, what do we have? We have, first of all, let's say that this is some solution which is containing some substance, or it is a gas or a solution, whatever you can assume, something through which we can pass light. We give it a white light. Okay, this is white light. Okay. Now, when the white light goes in, there will be atoms of the molecules which are present inside this solution here. Those atoms, they will, if they get the white light, and there will be some frequency which will match the gaps between the orbits. The energy gaps between the orbit, they will match it, and the electrons, they will absorb some energy. Now, let us suppose that the atoms which are present here, they have absorbed the, let us say, so they have absorbed, let us say, orange, yellow, and let us say indigo colors. Okay, so these are the colors that they have absorbed. And when this light will come back, so initially it was what? Initially we had VIBGOR. This white light is what? It is VIBGOR. Now, when this white light will come, transmit through this solution, what we will be getting? We will be getting violet, blue, green, and red. So we'll be getting only these colors. And in the spectrum here, we will be seeing not all the lights as a continuous spectrum. Rather, we will be seeing what colors? We will be seeing only the violet color, the blue color, the green color, and the red color. Okay. Now this is known as what? This is known as the absorption spectrum, because the thing has absorbed some electrons, absorbed some absorption frequency of light, and it has emitted the remaining. So it is known as the absorption spectrum. You got this? Yes or no? Please tell me.
So what solution is this?
Any solution you can take. Don't think about the solution exactly what it is. It can be any gas also, any solution. Okay, so in general, this is the absorption spectrum. Generally, you will be dealing with gases, not a solution, but in the definition, you have write the solution or a gas. Okay, so think of it like this. White light comes, it has multiple frequency. The atoms, it has multiple energy gaps. Some frequency will match the energy gap, and those frequency will be absorbed. The remaining will be transmitted, and then we will get a spectrum, which will be absorption spectrum. Okay, so here we'll be getting some lights. This is clean panel. There is nothing here. We are getting some violet, some blue, some green, some red, like this. Done? Yes or no? Please tell me.
Done, sir.
Okay. Write a note. Emission spectrum contains bright colored light, bright colored lights, lines separated by bright colored lines separated by dark spaces. Okay, and the absorption spectrum contains it contains dark lines separated by continuous spectrum. Okay, so these dark lines, है ना, जो भी वहाँ पे available हैं, that has been absorbed. Those dark lines. Let me give you a picture here. Yeah. Okay, so this is the continuous spectrum. In the emission spectrum, what will happen? Certain frequency will be emitted. Okay, so those frequency which has been emitted, we have got this color, emission spectrum. Now, if I take the absorption spectrum of the same substances, that means these frequency will be absorbed, and when these frequencies are absorbed, we will get dark lines there. That means the red has been absorbed, yellow has been absorbed, green and indigo and blue. Okay, so this is the difference between emission and absorption. In absorptions, we'll have dark lines separated by continuous spectrum, and in emission spectrum, we will have bright colored lines separated by dark spaces. Done? Yes or no? Please tell me. Done. Okay. All right. Next, hydrogen spectrum. What is hydrogen spectrum? The hydrogen spectrum is obtained by analyzing the light emitted by discharge tube containing hydrogen under high voltage and low pressure. Let me know when you're done.
Done.
What happened? Do not get wasted. No, wait a second. Decided to try something else. Just give me a second. There is no good image, it seems. Okay, this may work. Yeah. So the hydrogen spectrum, you can see almost like 4 lines there. There is one line which is very far away, the alpha line, which is having a wavelength of 656. Then we have lines which is 486 nanometer, 434, and then 410 nanometers. So these are the lines that we get. So can you please note down the values here? Please note down the values here. Done? Yes or no? Tell me. Shairam and Fahad, let me know when you're done.
Done.
Okay. Now, there was a scientist. He was known as, his name was Rydberg. Okay. And Rydberg was initially, he started this work on hydrogen spectrum. Okay. And even before Niels Bohr. So somewhere around 1888, I think, he started this work and he mentioned a few findings about hydrogen spectrum. And we all know now that we have here certain orbits. Okay, we have here certain orbits. And he said that, and then obviously Niels Bohr, he completed this theory. Okay, this was the observation of Rydberg, but Niels Bohr, he completed this theory. And all of these wavelengths that we are looking at, it must correspond to some energy levels, some difference in energy level. So if it passes from this energy level to this energy level, then it should emit some wavelength, and it should have, we should see that particular wavelength in our emission spectrum. And Rydberg, he formulated an equation. He said that the wave number of whatever light we are getting, it will be equal to 109,677. Okay, this is a constant that he said, divided by 1 upon let me tell you first of all this. Whatever wave number he was getting, it was inversely proportional to the difference. Okay, it was inversely proportional to the difference of the orbit number. If it is 3 or 4 like this, then it was inversely proportional to the difference of 1 upon n1 square and 1 upon n2 square. Okay, so he saw this mathematically. He saw this. Okay, he mathematically saw this, and he said, okay, fine. If we are seeing this proportionality here, then let me add a constant. So he added a constant here, and then he formulated the wave number is equal to this constant divided by n1 square minus 1 upon n2 square. Okay, so this is just a formula. Now, why do we need a formula? We need a formula because if I want to check the energy between, let us say 5th orbit and 6th orbit, then we can put up this formula here. We have this formula here. We will put up the value here, 5 to 6 में कितना energy है. So we will see, put up 5 here, we will put up 6 here, and then we can calculate the energy. Okay, so please write here is equal to Rydberg's constant. This 109,677 is Rydberg's constant into 1 upon n1 square minus 1 upon n2 square. Okay, so what is RH? RH is equal to 109,6. This will be in centimeter inverse, right? Because it is wave number, and centimeter inverse. 109,677 centimeter inverse. And what is n1? n1 is equal to the initial. n1 is equal to initial orbit. n2 is equal to the final orbit. Okay, so always n1 should be what? n1 should be lower than n2. Please remember. Otherwise, ये negative आ जाएगा. Wave number negative होना नहीं चाहिए. Okay, so whenever you have to find the difference between two different orbits, you should write n1 जो भी lower है. So it should be n1 should be lower than n2. ये याद रखिएगा. Okay. Now, what is wave number? If you remember, wave number is 1 upon lambda. So 1 upon lambda will be equal to RH 1 upon n1 square minus 1 upon n2 square. लिख लिया आप लोगों ने? ये सुनो प्लीज टेल मी.
सर n1 greater than n2 नहीं होना चाहिए?
नहीं, n2 should be greater. देखिए 1 upon n1 है ना, n1 छोटा होगा तो 1 upon n1 बड़ा होगा,
हाँ, 1 upon n1 yes.
है ना? ठीक है, ठीक. डन.
Yes, done.
ओके, सो लेट अस सी. हम लोग को एक वेवलेंथ मिला हुआ है, राइट? लेट अस सी. इफ आई पुट हियर, let us take one of the wavelengths here. Let's take one of the wavelengths here and then take n1 as 1 and then calculate the n2 and then calculate the n2. देखते हैं कि मतलब like are we getting any whole number or not. ठीक है, तो फिर पता चल जाएगा. I'm tell you what I'm trying to do here. So we'll take first of all lambda is equal to 410 nanometer. Okay, so 1 upon lambda 1 upon 410 into 10 to the power minus 9 meters. सेंटीमीटर में कितना हो जाएगा ये? What will be this in centimeter? Tell me. Wait, what happened? Yes, Aisha Iram Fahad. One upon 410 into 10 to the power minus 9. 1 मीटर में कितने सेंटीमीटर होते हैं? How many centimeters are there in 1 meter? Aisha Iram Fahad.
100.
10 to the power 2 सेंटीमीटर लिख सकते हैं. कितना हो जाएगा? ओके, देखिए नहीं आ रहा तो बैक टू बेसिक्स. ठीक है, नहीं अगर आ रहा समझ में एक बार में, बैक टू बेसिक्स. दिस विल बी इक्वल टू 10 to the power minus 7 सेंटीमीटर. सेंटीमीटर में क्यों ले रहे हैं? बिकॉज रेडबर्ग कांस्टेंट इज इन सेंटीमीटर्स. ओके, so this will be 109677 1 upon 1 square minus 1 upon n square, and this centimeter here, this centimeter inverse here, they will cancel each other out. And don't write abhi dekhiye sir aap log. Okay, and we'll have 1 upon 410 into 10 to the power minus 7 is equal to 109677 into 1 upon 1 square will be 1, but n square को उधर भेज देते हैं तो n square minus 1 upon n square. Any difficulty with this? Yes or no, please tell me. Any
No.
difficulty with this? No. Okay, fine. Now let us move on. We can write this as n square upon n square minus 1 will be equal to 109677 into 410 into 10 to the power minus 7. Okay, so I will not bother you guys with calculation. I will calculate it myself. 109, because I have to just show something. 677 into 410. This will be equal to how much? Equal to 109,677 410. 449,67570 into 10 to the power minus 7. So this is what? 1, 2, 3, 4, 5, 6, 7. So I can write this as 4.5. Correct? Yes or no? n square minus 1. ठीक है? Any difficulty till here? Please tell me yes or no. Aisha, Iram, Fahad. Yes, Aisha, Iram, Fahad. Any difficulty? No, na? With me till now? Yes, Aisha, tell me. Aisha,
No,
what
I
happened?
said no, sir.
Nothing, na? Okay. I hope you guys are with me. I'm not going too fast here. So this will be equal to how much? You have n square, na? So this will be n square and 4.5 n square minus 1. अब 1 को इधर ले जाते हैं और 4 n square को इधर ले जाते हैं, तो 4.5 n square minus n square. So this will be equal to 3.5 n square is equal to 1. So n square will be equal to 1 upon 3.5. है ना? And now we can see that n is coming. N is what? N is coming to be less than 1. Yes or no? N is less than 1 or no? n square less than 1 है तो n तो less than 1 होगा ही ना. कुछ गलत नहीं किया ना. प्लीज देख लीजिए एक बार. आयशा, रमन, फहद. फहद आप देखिए एक बार, सब कुछ सही है.
सर आप ये बता सकते हैं आपने ब्रैकेट कैसे खोला?
हाँ ठीक ठीक ठीक. ब्रैकेट में हमने मिस्टेक कर दिया. माय बैड माय बैड. 4.5 n square minus 4.5 होगा ना. सॉरी. सो 4.5 माइनस यहाँ पे 1 प्लस 4.5 इज इक्वल टू 4.5 n स्क्वायर हो जाएगा. अब सही है. यस आयशा.
यस.
ठीक है. So will be 5.5 upon 4.5 which will be equal to n square. कितना आ जाएगा ये?
तो ये 1 कहाँ से आया?
ये शायद यहाँ से आया.
नहीं तो मल्टीप्लाई हो गया ना 4.5 से.
अच्छा यहाँ पे n स्क्वायर नहीं. एक सेकंड सिर्फ 4.5 होगा ना. सो 4.5 इज इक्वल टू 4.5 n स्क्वायर माइनस n स्क्वायर. ये होगा 4.5 इज इक्वल टू 3.5 n स्क्वायर और n स्क्वायर हो जाएगा आपके पास 4.5 अपॉन 3.5. माय बैड. है ना. कुछ गलती में मिस्टेक नहीं किया ना हमने अभी तक. देखिए तो इज देयर एनी मिस्टेक? अभी सही है ना. 3.5 is equal to 1.28. So n will be equal to root of 1.28. Correct? Yes or no? है ना. n जो आ रहा है आपके पास कितना आ जाएगा? 1.131 है ना. n is coming to be equal to आप लोग प्लीज इसको एक्सेप्ट कर लीजिएगा. ये आप मल्टीप्लाई करके देख लीजिए. 1.13 है ना. 1.131. This n is coming to be. So can we say n is equal to 1? Can we say n is equal to 1? Tell me yes or no. Can we say n is equal to 1? Yes. Yes, Fahad. Can we say n is equal to 1?
Yes.
यहाँ पे देख के बताइए. मतलब n2 है जो हमारे पास. n2 जो है उसको हम 1 कह सकते हैं. अब यहाँ पे देख के बताइए. नहीं कह सकते है ना. So that means what we have taken as the initial, this is not right. है ना. This is not right. ये जो आपके पास this 1 है, this is not right. Let us take this as 2. तो 2 लेने के लिए क्या करते हैं हम यहीं पे थोड़ा चेंज कर लेते हैं बस. I can have everything same. बस आपके पास 2 की वजह से ये n स्क्वायर माइनस 4 हो जाएगा यहाँ पे. बाकी सब तो सेम रहेगा है ना. ये 4 हो जाएगा बिकॉज यहाँ पे n स्क्वायर है तो 2 का स्क्वायर 4 हो जाएगा. बताइए व्हाट डू यू गाइस थिंक. सही है ना. यस और नो.
Yes, yes.
करेक्ट है? नहीं करेक्ट
Yes,
नहीं है।
yes.
नहीं नहीं करेक्ट नहीं है।
Correct. Yes.
नहीं नहीं नहीं, यहाँ पे एलसीएम ले रहे हैं ना जब, तो वहां पे 4n स्क्वायर हो जाएगा, है ना? सो दिस विल बी 4n स्क्वायर माइनस, and you have to multiply here 4 also, right? Yes or no? So it will be n square minus 4 upon 4n square. यहाँ पे भी ये n square 4n square upon n square minus 4 हो जाएगा, और यहाँ पे ये 4n square is equal to 4.5 n square minus 4 हो जाएगा। अब ठीक है, I hope. What do you guys think? Make sense? Yes or no? Tell me. Aisha, Iram, and Fahad.
Yes.
I hope so. And let us see. Now again, we have to do 4.5 n square minus 4 into 4.5 is equal to 4n square. So 4 into 4.5 is equal to 18. So this 18 is equal to 4.5 n square minus 4n square, shall be equal to 0.5 n square, है ना? Which is equal to 18.
3 ऐसे।
So कितना आ जाएगा?
3 n equals to 3।
नहीं, थोड़ा जल्दी कर दिया आपने। 0.5 डिवीजन में जाएगा, 0.5 डिवीजन में जाएगा मतलब 18 अपॉन 1/2, है ना? तो ये हो जाएगा 36, है ना? 36 हो जाएगा। तो n इज इक्वल टू कितना आ जाएगा? n इज इक्वल टू कितना आ जाएगा? टेल मी। अरे अब तो
6.
बता दीजिए। हाँ,
6.
n इज इक्वल टू 6, है ना? तो n2 हमारे पास क्या है? 6 है। यानी कि जब वी हैव n1 इज इक्वल टू हाउ मच, n2 इज n1 हमारे पास 1 है, यानी कि when it is in the 6th orbit and when it is coming back to the first orbit, then it emits a light which is of wavelength how much? कितना wavelength लिया था हम लोगों ने? What was the wavelength? 410. Okay, so we took this
410.
ठीक है। तो जब 6 से ये फर्स्ट में आता है तो हमारे पास कौन सा आता है? 410 नैनोमीटर का एक वेवलेंथ आता है। ओके, नाउ इसी तरह के आपके पास, एंड एज यू कैन सी व्हाट वी आर चेंजिंग हियर, दिस इज द फर्स्ट ऑर्बिट में आ रहा है। उसके बाद वी विल सी दैट इन द सेकंड ऑर्बिट में कौन कौन सा आता है, फिर उसके बाद थर्ड ऑर्बिट में कौन कौन सा आता है, फोर्थ ऑर्बिट में कौन कौन सा आता है, एंड दैट लेड टू some kind of series. Okay, so Lyman, there were many series here. Let me give you. Okay, so see here. Listen very carefully. See the first line here. Starting point मत देखिए आप, end point देखिए. What is the end point of the first line? कहाँ पे रुक रहा है ये? It is transitioning from infinity, that means outside the atom, है ना? मतलब बहुत दूर, very far away. And where it is ending? Tell me. N is equal to कहाँ पे end हो रहा है? आयशा, इरम, फहद, जल्दी बताइए, एरो देख के बताना है। स्टार्ट हो रहा है यहाँ से and end हो रहा है यहाँ पे ना? So it is coming from infinity and going to which orbit? First, second, third, which orbit? आयशा, इरम, फहद, क्या पूछ लिया हमने? ज्यादा कुछ पूछ लिया क्या? At least turn the mic on, tell me.
तो समझ नहीं आया।
हम ये पूछ रहे हैं, तेरा ट्रांजिशन, ये क्या है ट्रांजिशन? जैसे हमने क्या दिखाया था, 6 to 1 दिखाया था ना, वैसे ये एरोस क्या दिखा रहे हैं? ट्रांजिशंस दिखा रहे हैं इलेक्ट्रॉन के। गॉट इट नाउ आयशा, इरम, फहद?
ओके।
नहीं, आयशा, इरम, डिड यू गेट
Yes.
दिस?
Yes.
Yes, okay, now you tell me. This first line here, where it is starting?
Infinity।
Infinity.
Okay, where is it ending? So where is it ending?
1.
1. What about the second one? Starting at 7, ending at
1.
third one. Aisha, Eram, please answer. बहुत आसान है, बोलते जाइए please, लेकिन that will help you remember things. Yes, Aisha and Eram. What about the third line? Where it is ending?
Ending.
Ah.
2.
Ending at
1.
fourth line. Where is it ending?
1.
This and this and this. So any line which ends at n is equal to 1, we call it the Lyman series. If it is ending at 1, it is doesn't matter where it is starting from. Doesn't matter where it is starting from, that will be Lyman series. If it ends on 2, we call that Balmer series. If it ends at 3, we call this partial series. If it ends at 4, we call this bracket. And the next one is P fund. Okay, so these are the different names. And why it is there? Please see. I will tell you. First of all, write with me. Write with me. Number 1 series here is Lyman series. Please write. Lyman series. Okay, Lyman series. Here n initial, or rather not n initial, I will write n final or n1. जो छोटा होता है, n1 छोटा होता है ना, n1 छोटा है, that will be equal to what? 1. Okay. Second, in the Balmer series, the n final where the electron is ending at, or n1, will be equal to 2. Partial series, the n final or n1 will be equal to 3. Fourth bracket, n final or n1 will be equal to 4. Fifth is P fund series, n final or n1 will be equal to 5. Let me know when you're done.
Done.
Done. Okay. Now, if n is the n1 is equal to 1 for Lyman series, n2 will be equal to what? It will start with 2, 3, 4, 5, 6, and so on. Yes or no? Because n2 will be always greater than n1. So whenever you are talking some about Lyman series, आपको बस क्या देंगे वो? They will tell you the n2. n1 आपको पता रहना चाहिए. Lyman के लिए n1 कितना है? 1. n2 for Balmer series will start from 3, 4, 5, 6, and so on. Similarly, Partial के लिए लिखिएगा कहाँ से स्टार्ट होगा, ब्रैकेट के लिए लिखिएगा कहाँ से स्टार्ट होगा, एंड पी फंड के लिए लिखिएगा कहाँ से स्टार्ट होगा, n2. n2 is greater than n1. Okay. So in questions, this is going to help. They will ask you to calculate a few wavelengths here or wave numbers, and for that they will tell you that it is of Lyman series, और वहां पे वो दे देंगे that n2 is equal to 4 or n2 is equal to 5. Then you must know what is n1. लिख लिया आप लोगों ने? So I hope, what is N2? Tell me for partial series. N2 will start from Aisha, Iram, and Fahad. Tell me. N2 will start from where?
4,
4. Very good.
5, 6.
So on. Bracket में it will start from 5, 6,
5,
7,
6,
and
7.
so on. है ना? And in P1 it will start from 6, 7, 8, 9, and so on. ठीक है? So it is. I understand it must be difficult to learn. It was difficult to learn for me also in 11th standard. So I came up with a very weird mnemonic or trick. I call it LBAPA bracket fund. LBAPA bracket fund. LBAPA. है ना? Doesn't make sense, but repeat it 10 times. है ना? It will not make sense. Repeat it 10 times. Similar things I did with periodic table also. Some of them I got some tricks. Some of them I did not get trick. Okay, so you come up with something weird on your own, then it is good. And I remember this because I created this LBAPA bracket fund. So LBAPA 1, 2, 3, 4, 5. LBAPA bracket fund. How will you remember, Aisha? Yes, Aisha. How will you? LBAPA bracket fund. And if you can come up with something of your own, that will be better. But I have this weird thing. LBAPA bracket fund. LBAPA bracket fund. For BA because it was LBPBP, इसमें confuse हो जा रहे थे हम. Then I said that okay fine. LBAPA Balmer Passion bracket fund. LBAPA bracket fund. Done. Now let us write a question. Calculate the ratio of wavelength of first spectral line. Calculate the ratio of wavelength of first spectral line. Wavelength of first spectral line of Lyman series and Balmer series of Lyman series and Balmer series. What they are asking? They're asking the first spectral line. ठीक है? First spectral line. अब ये बताइए Lyman में N1 कितना होगा? Lyman में N1 will be, what will be N1 in Lyman?
1.
And first spectral line जो होगा वो कहां से आ रहा होगा? N2 is equal to पहला जो spectral line होगा that will be coming from
2.
second shell, right? 2. Very good. Intuitive है. For Balmer N1 will be equal to
2.
Very good. LBA and N2 will be equal to 3. Correct? Yes or no? Please tell me. Right. And from here we can write 1 upon lambda. It will be equal to RH into 1 upon 1 square minus 1 upon 2 square. This is 1 upon lambda. आपके पास किसके लिए आ रहा है? L के लिए आ रहा है. And 1 upon lambda for Balmer series, it will be equal to RH 1 upon 2 square minus 1 upon 3 square. Right. And then this is the first equation, second equation. इन दोनों का आप रेशियो ले लीजिए. So I will get 1 upon lambda L upon 1 upon lambda B is equal to RH into 1 upon 1 square minus 1 upon 4 लिख लीजिए आप. यहाँ पे RH in 1 upon 4 minus 1 upon 9. तो आपको दिख रहा होगा कि RH cancel हो जाएगा. And then you will get this as denominator of denominator is numerator. This will be equal to how much? ये आपके पास आ जाएगा कितना? 1 upon 1 minus 3/4 हो जाएगा ये. Divide by. This will be 9 4s are 36. तो 9 minus 4 upon 36 ऐसे ही कुछ होगा, right? ये लिखा ना हमने. Yes or no? Implies that will be equal to 36 को ऊपर भेज देते हैं, 9 - 4 आपके पास 5 हो जाएगा, ये हो जाएगा 3 × 36 अपॉन 4 × 5। ये सर नो सही जा रहे नहीं जा रहे?
(27/5).
Yes,
आ
sir.
रहा है,
27.5.
ठीक है, लेकिन आपको भी पता है ये आंसर ना गलत हो जाएगा आपका। हम बताएं क्यों? 27 अपॉन कितना आ रहा है?
5.
5। ठीक है, नहीं नहीं मतलब बता रहे, बस छोटी सी मतलब जो गलती आप लोग कर सकते हैं वो ये होगा ना कि इन्होंने क्या बोला है, रेशियो बिटवीन लाइमन एंड बार्मन, हमने क्या निकाल दिया है, बार्मन एंड लाइमन, है ना। बस इसको आप अपोजिट कर लीजिएगा याद करके, इज इक्वल टू 5/27। तो रेशियो जो आपके पास होगा ना, दो ऑप्शन दिए रहेंगे, 27:5 और एक दिया रहेगा 5:27। ठीक है, तो याद रखिए लाइमन एंड बार्मन दिया है, तो लाइमन ऊपर रहेगा, बार्मन नीचे रहेगा, इसको आप मान दीजिएगा। ठीक, डन? यस और नो, प्लीज टेल मी। डन? आगे बढ़े, आगे बढ़े। अरे हाँ या ना तो बोलिए। आयशा, एरम फहद लिख रहे हैं क्या? अच्छा,
Done,
नहीं,
sir.
हो गया।
तो फिर बोलती ही नहीं आप लोग। लाइन लिखिए आप, Rydberg's formula for hydrogen like atoms. So जो Rydberg का जनरल फॉर्मूला था, it was 1 upon, actually it was generalized later on, 1 upon lambda is equal to the Rydberg's constant, everything is same, 1 upon n1 square minus 1 upon n2 square into the z square. If I have anything other than hydrogen, then we will multiply also what? Z. So बाकी सबका तो आपको पता है क्या है, Z is equal to the atomic number. Done? Yes or no, please tell me.
Yes.
Okay. Now, I'll take a bit more time than usual today. Write a wave mechanical model of an atom. Wave mechanical model of atom. Write with me. This model gives the idea of wave nature of electrons. Please write the three-dimensional wave associated with electron is given by Schrodinger. Is given by Schrodinger equation. लिख लीजिए, इससे पता चल रहा है कि Schrodinger ने दिया था. What is the Schrodinger equation? The partial derivative of psi upon the x plane plus the partial derivative of psi in y plus the partial derivative of psi in z plus the value 8 pi square m e minus v of psi is equal to 0. This is time independent Schrodinger wave equation. So this wave equation does not depend on time, it only depends on position. कुछ नहीं करना है, बस आपकी नोटबुक में रहना चाहिए. Okay. What are x, y, and z? These are the coordinates. X, y, z. These are the coordinates. Okay. What is psi? This is psi. psi लिखते हैं. Pronunciation में psi है. This is wave function. This is wave function. E is the total energy of electron and V is the potential energy of electron. V is the potential energy of electron. Now, अगर आपको ये इक्वेशन बहुत ही भारी लग रहा है तो फिर आप इसको बहुत ही आसानी से लिख सकते हैं. This whole thing is known as Hamiltonian. Okay, if I put E here, if I put E minus V and expand this bracket, then this whole thing is known as Hamiltonian. So Hamiltonian को लिखते हैं H cap. H को आप एक ऊपर से कैप बना दीजिए. H cap psi is equal to E psi. So Hamiltonian operator होता है. तो धीरे धीरे जो मैथ्स होता है ना, इट गेट्स कॉम्प्लिकेटेड. जैसे आप लोग सबसे पहले क्या पढ़ते हैं, नंबर्स पढ़ते हैं 1 2 3 4, देन यू गो टू वेरिएबल x y z एंड सो ऑन. देन आफ्टर वेरिएबल यू गो टू फंक्शन. फंक्शन में क्या होता है, वी से दैट y इज इक्वल टू फंक्शन ऑफ x. दैट मींस इफ आई चेंज द वैल्यू ऑफ x, देन y इज गोइंग टू चेंज. नाउ अ लेवल अबव फंक्शन इज नोन एज ऑपरेटर. अ लेवल अबव function is known as operator. Now energy is a function. Okay, now if I change anything in the Hamiltonian, the energy is going to change. So energy E psi, देखें यहाँ पे क्या आपके पास E psi is equal to H cap of psi. If anything changes here, then the energy associated with psi is also going to change. So this is one level above functions. Okay, तो मैथ भी आप लोग को उतना नहीं पढ़ाया गया, तो उसके बारे में आप लोग चिंता मत कीजिए, कुछ नहीं आएगा इससे आप लोग को. बट जस्ट कीप इट हियर. क्या पता कभी पूछ दे सीबीएसई, बिकॉज सीबीएसई ने दिया हुआ है ना, इट इज गिवन दिस इक्वेशंस इन द एनसीईआरटी. थोड़ा सा बस चीजों को समझ लीजिए, फील ले लीजिए दैट हैमिल्टोनियन, दिस ऑपरेटर इज व्हाट, इट इज वन लेवल अबव द फंक्शंस. ओके, डन? यस और नो, प्लीज टेल मी. इसको हम लिखा देते हैं. व्हाट इज एच कैप? इट इज द हैमिल्टोनियन operator. Simply done with this one. Yes or no, please tell me. आगे बढ़े हम. एक तो चीज और लिखानी है बस. About psi. See, each and every wave, it will be associated with something which is known as amplitude. Right. So this here is what? It is the amplitude. Okay. Now wave का जो amplitude होता है वही psi है. Psi is nothing else. Okay. Psi is the amplitude of wave that is associated with the electron. Please note here. Write some notes. तो घबराने वाली बात नहीं है. Psi is the amplitude of wave associated with electron. Okay, wave associated with electron. Now psi as amplitude, it does not have any physical significance. Psi does not have any physical significance. But we should know that psi is what? You know that psi is as amplitude, and we know amplitude square is what? It gives me intensity. That means if I do psi square, it will also give me intensity of electron that is present. And intensity means what? The probability of finding electron. If the psi is intense at some particular position, XYZ coordinate, that means the probability of finding electron is most probable there. Finding of electron is highly there. Psi square is directly proportional to intensity. मान लीजिए यहाँ पे आपके पास जो हम लोग p orbital बनाते हैं ना ऐसे. So we have the highest intensity in this area. And that is why we say that the probability of finding electron is highest in these parts, these lobes. So we'll write psi square is proportional to probability. अच्छा intensity तक रखिए, इसको लाइन में लिखा देते हैं. Psi square gives the probability of finding electron. Probability of finding electron per volume. Just a minute now. Hello. Okay, I'm sorry for that. Okay, so psi square gives the probability of finding electron per volume. Per unit volume आपको लिख लीजिए. Whatever volume we are taking XYZ के हिसाब से. And therefore, psi square has physical significance. Okay, so the only question they can ask from here is what? They can ask, psi does not have any physical significance, but why psi square has physical significance? Then you will see that psi is amplitude. Amplitude does not have any physical significance. But if I talk about the psi square and amplitude square, it gives the intensity. And in terms of psi square gives the probability of finding electron per unit volume. That is why psi square has physical significance and psi does not have any physical significance. Is that clear? Yes or no? Tell me. Guys, Aisha, Iram, and Fahad. If they ask you what is the difference between psi and psi square, can you answer now? Yes, Aisha, Iram, Fahad. आवाज ही
Yes.
नहीं आ रही आप लोग की। आयशा इरम सो गए क्या आप लोग? यस अरम एंड आयशा, एम आई ऑडिबल? नो, ओके, आयशा एंड इरम आर नॉट हियर।
हाँ सर।
क्या हाँ सर? व्हाट हाँ सर?
सर क्या पूछ रहे थे आप?
सो यू वर नॉट हियर? यस इरम?
नो आई वाज हियर सर।
No, no, you were not here. Then you would have listened to me now. फहद, आपको सुनाई दिया था क्या हमने पूछा?
Yes.
Yes. एंड इरम, आपको सुनाई नहीं दिया क्या हमने पूछा?
सॉरी सर, थोड़ी डिस्टरबेंस थी इधर।
अच्छा, चलिए, if you are done let me know. Done guys? Yes or no, please tell me.
Done, sir.
चलिए. So that is the end of the chapter. Okay, I hope everything is completed ना. सब कुछ तो कर लिया हम लोग ने. वेब मैकेनिकल मॉडल तक आ गए, एग्जाम में कंस्ट्रक्शन प्रिंसिपल हो गया.